Welcome. In this session, we would understand what are anticyclones. We have talked about what are cyclones, the types of cyclones. Now, similar to cyclones, we have another phenomena which is known as anticyclone, and as the word anti denotes opposite, so we can say it's opposite of what is cyclone. So you would have a high pressure area, and this high pressure area would lead to divergence of wind. So you have wind that blows from high pressure to low pressure, and this force is known as the pressure gradient force that we have already talked about. Now, creation of low pressure area leads to formation of cyclonic activities. However, creation of high pressure area lead to formation of anticyclonic activities. So Galton was the first person who in 1860 propounded that there is presence of anticyclonic conditions. Then under anticyclonic conditions, you have usually circular isobars which are at a distance of around 1000 millibars away or more. That is usually what they are denoted with. The basic characteristics of anticyclonic condition would be subsidence of the air and divergence of the air. So whenever you have, say I have this surface, and on this surface you have a anticyclonic condition that is formed, that means this region would be a region of high pressure. So what would happen is there would be subsidence of the wind, and once the wind is subsiding here, there would be divergence of the wind. So two basic characteristics associated with anticyclonic condition. The first is subsidence and the second is divergence. While opposite to what happened with the cyclonic conditions in North Hemisphere and South Hemisphere, you have the anticyclones which move clockwise in North Hemisphere and they move anti-clockwise in South Hemisphere. So opposite to what cyclones move, anticyclones move clockwise in North Hemisphere and anti-clockwise in South Hemisphere. Now here this diagram explains a difference between the cyclonic activity and anticyclonic activity. So you have the northern hemisphere where you have the anticyclone which is clockwise and cyclonic condition which is anti-clockwise. Now when we talk about the types of anticyclones, I can say we can classify it as cold anticyclones, warm anticyclones and blocking anticyclones. So these are the three basic categories: cold, warm and blocking. Now what does cold stand for? Cold stands for a high pressure area which is created by a cold region which is considerably more colder as compared to the surrounding areas. So the region, the high pressure region that we are talking about is much colder or much cold as compared to the surrounding region. So it's more cold, and this would lead to condition which is cold anticyclonic condition. It occurs mainly in the continental interiors of Siberia and the northern parts of northern hemisphere. The basic reason for it is the radiational cooling that takes place. So radiational cooling, I can say, is the major cause for cold anticyclonic conditions. Now these cold anticyclonic conditions can either be permanent in nature or they can be temporary in nature. Now what is the difference between permanent and temporary? Permanent, which means there is continuously a high pressure zone or a high pressure area that has been that is continuously being fed by air or subsidence of air from all sides. That would be a permanent cold zone, for example polar cell, and this polar cell would be example of permanently cold anticyclonic condition, for example in Siberia in winters. Now what is temporarily cold anticyclonic condition? I can say the region which lies between mid latitude and the subtropical high latitude would be a region of temporarily cold anticyclonic conditions, because you won't see a high pressure area that is created there forever. It would change based on the winters and the seasons. So it would change based on land and sea and winters and summers. So that would be a temporary anticyclonic condition which is cold. Now let's move on to warm anticyclonic conditions. warm anticyclonic conditions, by and large the high pressure area in warm anticyclonic region occurs, which is much larger than the warm air that surrounds it. So it results into convergence that occurs in upper troposphere. So you have convergence of air at upper troposphere, and that would lead to a high pressure zone or a high pressure area which is warm, mainly seen in the mid latitude areas. This again can be further divided into two: the temporary warm anticyclonic conditions and the permanently warm anticyclonic conditions. The permanently warm anticyclonic conditions are associated with fine weather, clear skies and warm weather. However, the temporary anticyclonic conditions, as I said, would be again in this region, would be lying between the subtropical region and the cold anticyclonic conditions. Usually that is the region where you would have the temporary anticyclonic conditions which are warm in nature, and it would lead to cloud formation. Then finally you have the blocking anticyclonic conditions. Blocking anticyclonic conditions occur when the cell break away or moves away from the azure highs. So this is a condition when I can say blocking anticyclonic condition occurs, usually seen in warmer months, influenced by warm anticyclonic conditions, and they are also influenced by the jet stream patterns, which is east to west, and the zonal pattern north to south. So you have east to west and north to south, which is the zonal pattern. So these two are the cases which are affected by the blocking anticyclonic conditions. And finally, this would lead to exceptional weather conditions. It can be exceptionally cold weather conditions or exceptionally hot weather conditions. So those exceptional categories are governed under the blocking anticyclonic conditions. Now if we broadly classify the differences between the cold and the warm anticyclones, I can say you have a summary of things that is given here, but in brief I can say the troposphere would be colder in cold anticyclonic conditions, while the stratosphere layers would be warmer, and the reverse would happen in the warm anticyclonic conditions. Then you have the regions of Siberia where you would have cold anticyclonic conditions, in contrast to Bermuda, Greenland and North Canada, which would be the regions of the warm anticyclonic conditions. Then you would have the cold anticyclone, which is less persistent as compared to the warm anticyclonic conditions. However, the cold anticyclonic conditions are more or less immobile, and they extend for up to kilometers and kilometers of dimension. The next is anticyclonic conditions to cyclonic conditions. Now in this we will understand how you have the air that subsides here. So when it's subsiding here, you would have divergence from this region. So this would be an area of high pressure. This diverging wind from high pressure would move to a region which would be low pressure, and since all the wind is converging at low pressure, it would become hot, and once it becomes hot, it would rise up, and this would be a cyclonic area. So for every region I can say there is a anticyclonic condition associated with the cyclonic condition. Or when we talk about the three model cell, we talked about the air circulations that could be seen in the headless cell, Ferrel cell and the polar cell, and the similar feature occurred there. So you have the high region, the high pressure belt, the low pressure belt, and so on, and the winds move from high pressure to low pressure. So I can say the region of low pressure would usually have cyclonic conditions, while the region of high pressure would have anticyclonic conditions. The characteristics of anticyclonic conditions or the effect of anticyclonic conditions are primarily fine weather, clear skies, stratus clouds. Fog would be formed only in the region of high pressure. Now anticyclonic condition, based on the origin, whether it's a cold anticyclone or warm anticyclone. If it is a cold anticyclone, it would bring misery in the months of winters. However, if it is a warm anticyclonic condition, it would lead to clear skies during the base. Now anticyclonic formation, if I talk about, I can say it can be formed either at the surface, as you have seen in this case. So it would be at the surface, and the other would be in the air. That would be in the case of anticyclone. So under anticyclone, what is happening? You have a cyclonic condition which is happening at the surface, and as you move up you would have the spiral movement of the air and outward flow of the air, and that would lead to divergence in the upper atmosphere. So in the air you would have an anticyclonic condition. So what is happening here is the hot air is rising up, it is being heated by the latent heat of condensation, then the temperature is rising, the pressure is rising, and finally you have a outflow of air that is generated in the upper atmosphere. However, there would be subsidence in case of surface temperature. It usually occurs at a 30-degree parallel area, the region of 30th parallel, I can say. So you have a subsidence of the wind that could be seen here, and that would be the region of high pressure at the surface. So you have two formations that we can understand for cyclonic conditions. One is at the surface, the other is at the air. Now finally, what is the difference between cyclone and anticyclone? In the very broad sense, I can say the focus of a anticyclone or the pressure zone would be high pressure, while in cyclone it would be a low pressure zone. So anticyclones move clockwise in north hemisphere, vice versa to cyclone, and this happens vice versa in south hemisphere as well. So cyclonic condition in north hemisphere and anticyclonic condition in south hemisphere. Then you have subsidence and divergence as we talked about right now in case of anticyclone, and the reverse happens in cyclonic conditions. Cyclonic conditions, as we said, you have clear skies, fine weather, so you have weak wind speed with dry rainfall conditions, in contrast to cyclone where you would have intense rainfall and strong winds that would be blowing. The clouds are basically either no clouds or stratus clouds could be seen. However, in case of cyclonic condition, you would be having rain bearing clouds, that is nimbo clouds or the nimbus clouds. So you have cumulonimbus and nimbostratus clouds. Usually anticyclonic condition is seen with a stable atmosphere. However, cyclonic conditions have unstable atmosphere with huge gush of wind and large scale destruction in extreme cases. The temperature contrast is not much high for anticyclonic conditions. However, there is strong temperature contrast that could be seen that could lead to cyclonic conditions, as we have already discussed in the class on cyclonic conditions, on cyclones. So these are the basic differences between anticyclones and cyclones. We will be covering further topics related to climatology. There are just a few that remain. In the subsequent classes, you can subscribe to our channel for any further updates. Have a good day ahead.